Hi you guys. This week we're going to look at another 4 valid inference rules for the process of natural deduction and completing proofs in natural deduction. Let's go ahead and get started. Let's start with the simplification rule. The rule states, if you start with a conjunction, like P and Q, then you can infer the first conjunct, P. You can also infer the second conjunct, Q. See the form, P and Q. From the conjunction, we can infer P. Also, we can infer Q. Notice the substituted instance, A and B. We can infer A, and we can also infer B. Okay, let's talk about the conjunction rule. If you start with the sentences P and Q, separate from each other, then you can infer the conjunction P and Q. Let's take a look at the form. Notice P and Q, so we can infer the conjunction brought together by the ampersand, P and Q. From the two simple sentences, we can infer the compound sentence, the conjunction. Notice the substituted instance, A and B, so we can infer the conjunction A and B. Okay, let's talk about the addition rule. If you start with sentence P, then you can infer the disjunction P or Q with any sentence Q. So this could be A, B, C, D, E, F, and so on. Any sentence you can infer as the second disjunct if you start with a simple sentence. Let's take a look at the form. You see P, and so we can infer P or Q. Notice the substituted instance. You see A, and so we can infer A or R. We can understand this maybe a little bit more clearly in English. If I make the statement, Alex is going to the movies, I could reasonably infer Alex is going to the movies or Robert is going to the movies. Okay, let's take a look at the constructive dilemma rule. Now, this rule is a little bit more complicated. There are 3 elements required. You need one conditional, you need a second conditional, and you need one disjunction, where the first disjunct is the antecedent of one of the 2 conditionals, and where the second disjunct is the antecedent of the other conditional. From this you can infer another disjunction, one where the 2 disjuncts are the consequences of the 2 corresponding conditionals. So from the instance, if P then Q, and the instance, if R then S, and the corresponding P or R, then you may infer Q or S. Let's take a look at the form. You see the given information. If P then Q, if R then S, P or R, therefore Q or S. Notice the substituted instance. If A then B, if C then D, A or C, so we may infer B or D. Okay, let's put the 4 valid inference rules to work. First, let's take a look at the simplification rule. I provided an example for you. The given information, premise 1, X and Y. Premise 2, if X then E, therefore E. So what can we infer here? The first inferred premise is X, based on the simplification rule, as it is the first conjunct of the conjunction X and Y. Once we infer X, then we can infer E, based on the modus ponens rule, premise 2, and the inferred premise 3, because X is the antecedent of the conditional, if X then E, in premise 2. So you see how the simplification rule works. Let's see how the conjunction rule works. You see the given information. Premise 1, X. Premise 2, Y. Premise 3. If x and y, then e. Therefore, e. So what can we infer? In the first inferred premise is x and y, based on the conjunction rule, premises 1 and 2. Given the sentences x and y by themselves, we can infer the conjunction based on the conjunction rule. You can combine the true sentences that stand alone into a conjunction. Once we infer x and y based on the conjunction rule, then we can infer e based on a modus ponens, premise 3 and 4. Because the conjunction x and y is the antecedent of the conditional if x and y, then e. Okay, let's take a look at how the addition rule works. You see the example. First premise of the given information, x. Second premise, if x or h, then r. Therefore, r. Okay, what can we infer based on the addition rule? Infer premise 3, x or h, based on addition 1. See, given x in premise 1, you can infer a disjunction with any sentence as your second disjunct. It makes sense for us to infer x or h to add the h as the second disjunct, because x or h is the antecedent of the conditional in premise 2. If x or h, then r. Once we infer x or h based on the addition rule, then we can infer r based on the modus ponens, premise 2 and 3. All right, now let's take a look at how the constructive dilemma rule works. Let's take a look at the given information. Premise 1, if h, then if x, then y. Premise 2, if k, then a and d. Premise 3, h. Therefore, if x, then y, or a and d. Okay, this one seems a little complicated, but once we find the constructive dilemma rule in action, we can put it all together. First question you ask yourself, what can you infer? Well, because there is an h by itself, we can infer h or k based on the addition rule, premise 3. Given h in premise 3, you can infer a disjunction with any sentence as the second disjunct. You'll want to pick k. H is the antecedent of the conditional in premise 1, and k is the antecedent of the conditional in premise 2. So h or k gives us the 3 elements you need to complete a constructive dilemma inference and to complete the proof. Once you have inferred h or k, you can put your constructive dilemma rule to work and go ahead and infer the conclusion. If x, then y, or a and d, based on constructive dilemma, premise 1, 2, and 4. So let's look at all of those elements together. Premise 1 states, if h, then if x, then y. Premise 2 states, if k, then a and d. Premise 4 states h or k. Notice the 2 disjuncts of that disjunction are the antecedents of the conditional in premise 1 and premise 2. So, we can infer, based on the constructive dilemma rule, the consequence in a disjunction. If x, then y, or a and d. Alright guys, so those are the 4 valid inference rules that we are studying in Chapter 19 this week. Your assignments for the week include 19.1 and 19.2. I decided to write out some examples for you guys from 19.1 and 19.2, go over them with you in the video so that you can just see an example of how all 8 rules come together to solve these proofs in natural deduction. Let's go ahead and look at the first example 19.1, number 2. You'll see the given information is 5 premises. Premise 1, if H then S. Premise 2, B. Premise 3, R. Premise 4, if B and R, then tilde S. Premise 5, if tilde H, then Z. Therefore, Z or I. Okay, so the first thing you want to do is you want to look at the given information, and based on the 4 rules from chapter 18 and the 4 rules that we just went over, ask yourself, what can we put together? What can we infer validly? The first thing I saw was a conjunction. You can infer the conjunction B and R based on premise 2 and premise 3 of the given information. You see premise 2 of the given information is B, and premise 3 is R. So we can correctly infer the conjunction B and R. What else can we infer? Well, after we have the conjunction B and R, notice that is the antecedent of the conditional in premise 4. And so we can infer not S based on a modus ponens 4 and 6. Once we have not S, you'll notice that S is the consequent of a conditional in premise 1. So we can infer not H based on the modus tollens rule, premises 1 and 5. Not H is the antecedent of the conditional in premise 5. So based on our inference in premise 8, we can infer Z, modus ponens 5 and 8. Once we have Z, we can infer Z or I based on the addition rule, because in premise 9 you have Z by itself, and so according to the addition rule you are perfectly correct in inferring a disjunction with any sentence as your second disjunct. You can infer Z or I based on addition rule 9. Okay, let's go ahead and take a look at one from 19.2. 19.2, number 11. Let's check out the given information. If H or S, then D. If R or M, then I. If D and I, then not A. H and R, therefore not A. All right, what can we infer? Well, given the conjunction in premise 4, we can use the simplification rule to infer H by itself. We can also use the simplification rule to infer R by itself. Once we have inferred H by itself, we can use the addition rule to infer the disjunction H or S. Once we have inferred R by itself, we can use the addition rule to infer the disjunction R or M. Once we have inferred the disjunction H or S, then we can infer D based on modus ponens rule 1 and 7. Once we have inferred the disjunction R or M, then we can infer I based on the modus ponens rule again 2 and 8. Once we have inferred D and I by themselves in premises 9 and 10, we can infer the conjunction D and I. And once we have inferred the conjunction D and I, we can infer not A based on a modus ponens rule 3 and 11. So I think this one is a really good example of how the new rules work together with the old 4 rules that you learned last week. Okay, let's look at one more example. 19.2, number 16. Notice the given information. You have a conditional. The antecedent is, it's not the case that I. The consequent is, if C, then E. In premise 2, you have another conditional. The antecedent is the disjunction, B or D. And the consequent is another larger conditional. If F, then G and Z. Premise 3, you have a disjunction, I or B or D. Premise 4, you have a conjunction. It's not the case that I and C or F. The conclusion, E or G and Z. Okay, so what are we going to do first? Ask yourself the question, what can we infer based on the new set of rules that we've learned this week and based on the first 4 rules that we learned in Chapter 18? The first thing you can infer is the not I based by itself based on the simplification rule. Premise 4 is a conjunction, which means you can infer those conjuncts by themselves based on the simplification rule. What next? Once you have that not I by itself, then you can infer the conditional, if C then E, based on the modus ponens. You'll notice the conditional in premise 1, if C then E is the consequent, and not I is the antecedent. So having that not I by itself allows you to perform the modus ponens. What else can you perform with the not I? You can perform a disjunctive syllogism. Notice premise 3, a disjunction, I or B or D. With the not I of premise 5, you can infer B or D, disjunctive syllogism 3 and 5. Once you have that B or D by itself, look back up at premise 2. You'll notice that you can infer the consequent of that conditional based on the modus ponens rule. The consequent of that conditional, if F, then G and Z, now stands alone in the inferred premise 8. Once you have inferred premise 8, go ahead and simplify the conjunction of premise 4 in another way and get that disjunction by itself, the second conjunct, C or F. Once you have inferred the disjunction, C or F, you'll notice that you'll have the 3 elements needed to perform the constructive dilemma rule. C is the antecedent of the conditional, if C then E. F is the antecedent of the conditional, if F then G and Z. You have one conditional, you have another conditional, and then you have the disjunction, where the disjuncts are made up of the antecedents of those 2 conditionals. And so, you can validly infer another disjunction made of the consequence of the 2 conditionals, E or G and Z, based on constructive dilemma 6, 8, and 9. So the key is to get comfortable using the constructive dilemma. Recognize when it's necessary to solve the proof and structure your inferences around the 3 elements the constructive dilemma needs. Alright guys, that's all I have for you this week. Hope you have a good week and get through the material easy enough. Message me with any questions.